Hello everyone, it's Mo at Pareto with another pixel here today. And today we're going to be speaking about troponin because troponin is quite a tricky biomarker, but an incredibly important biomarker in differentiating different stages and different types of acute coronary syndrome. So let's get going. So ACS or acute coronary syndrome is essentially describing a spectrum of disease. You start off with stable angina, which is completely different, but it's important to mention, which is brief discomfort during exertion or emotional stress, and essentially correlates to significant stenosis of the coronary artery, usually reversible with some GTN. ACS is characterized by irreversibility to begin with. Unstable angina, for example, it specifically correlates with some thrombi that partially occlude but don't completely occlude the coronary vessels. And NSTEMI and STEMI are a lot more significant, where there's more than 70% of stenosis or occlusion of the coronary vessels. And troponin is really important in differentiating the different stages of the spectrum. Ischemia, or to define things to begin with, ischemia is the result of impaired blood flow, and it really describes the deprivation of cardiac tissue of vital nutrients such as oxygen, and the effects are irreversible. Infarction, on the other hand, refers to the death of tissues as a result of ischemia, which is irreversible. Now, troponin specifically is a protein which is responsible for cardiac contraction, and it's released in great quantities by dying cardiac myocytes. We repeat the level of troponin at different intervals to see if it's increasing, decreasing, or staying the same, and that allows us to rule in or rule out an NSTEMI. And I mention NSTEMI because troponin is only released when there is active death of cardiac muscle, not when there's only a process of ischemia. I say only, I mean, both are bad, but when there's actual necrosis or death of cardiac muscle. So troponin increases in the context of an NSTEMI or a STEMI, but doesn't increase in the case of unstable angina. Here's a useful table that summarizes everything. So in stable angina, unstable angina, NSTEMI and STEMI, you get the same type of pain. In unstable angina, you can get ECG changes such as T-wave inversion and ST depression. However, troponin stays normal. In an NSTEMI, you can get a T-wave inversion or ST depression on ECG, but troponin rises. And in STEMI, of course, we know the characteristic increase in the ST segment, and of course, troponin rises. So I hope that's a useful summary for you all. Troponin is incredibly important, but it's important to know when it rises and when it doesn't, so that you're able to answer SBAs efficiently. And that's it for this pixel. So hopefully this pixel is clearer for you. So until next time, see you later.